This video we're going to look at numerical methods, and the first thing we're going to look at is finding the roots of equations and showing that there is a root lying between a range of values. So to do this, first thing we have to look at is a function and see that it is a continuous function. So this is a continuous function. As I can draw it, basically I can draw it without lifting the pen from my page. So I can just draw it all the way along. If I look down at one to show you one which isn't a continuous function, one like this would not be a continuous function because it goes down this way, and then I have to lift my pen to get up to here to draw the rest of the curve. So this would not be a continuous function all the way along. Okay, this one is fine, and more importantly, it's continuous between the bits we're looking for. Now, basically, you're trying to find a root of an equation is where your equation crosses the x-axis. That's what a root is. So here you can clearly see there's a root at this point as it crosses the x-axis. But maybe you don't know where the root is exactly, or maybe you're trying to find roughly where it is. So if I know it's a continuous function and I look here, I could maybe work out that f of 2, so this is my x value is 1, 2 here, so f of 2 is equal to, and it works out in this case to be minus 1. Now what it is, numerically, the size of it isn't particularly important, but the sign of it is important, so whether it is positive or negative. Likewise here, this is 4, so at this point here, x is equal to 4, so f of 4 would be equal to, and again, it's going to be 1, but it is positive 1. So we've gone from negative to positive, and because it's a continuous function, then that means it's gone from negative up to positive. There has to be some point where it crosses, so it is 0. So your f of x is equal to 0, which means there is a root. So that is it. Okay, just to show you in this next graph, we have, this is a curve y is equal to 1 over 2x minus 1, or f of x is equal to 1 over 2x minus 1. I'm going to show you basically why there is a break, or why there is what's called a discontinuity in this graph. Okay, so if you look at this graph, the equation of this graph is 1 over 2x minus 1. So basically in mathematics, if you have a 0 on the bottom line, it's a problem. So we're going to find out where this 0 on the bottom line is. So put your bottom line equal to 0. That's what we'll have. 2x minus 1 is equal to a half. 2x minus 1 is equal to 0, which means 2x minus 1, 2x is equal to 1, which means x is equal to a half. So there's a 0 on the bottom line when x equals a half, and look at the graph. At x equals a half, that's where your break in your line is and your curve is. So that's where the discontinuity is, and that's it. So when you're looking at these questions, it's good to have a look and think, is there anywhere it's going to be a problem to me? Is there anywhere it's going to have a 0 on the bottom line? Okay, we're going to jump on to a couple of examples now, please, and you'll see they're very easy, quick and easy to do. Okay, so in this example, first thing you're going to do is say is let f of x equal 3 plus 4x minus x to the 4, and then we're just going to put in f of 1, find out what f of 1 is, find out what f of 2 is, and then see if their signs are different. So just firing 1 into this, and really I would do this with my calculator. That's what I would have. Put it in, it would be 6, fire in 2, it's going to be 3 plus 8 minus 16, which is going to be minus 5. Again, we're not really caring too much in what the values are, so 6 and minus 5, we don't really care, or 5, 6 and 5, we don't really care, but we do care that the sign has changed. So then you say f of x is continuous. F of x is continuous between x equals 1 and x equals 2. And there is a change in sign. So that means, so there is a root between x equals 1 and x equals 2. Okay, this next example says, show that sine x is equal to ln x has a root between 2 and 3. So first thing I'm going to do is I'm going to say let f of x equal, you've got to bring it all to one side, so there's a 0 somewhere, so sine x minus ln x. So we want to find if, basically to find a root, we want to find when sine x minus ln x equals 0, but we just want to show that the root lies between 2 and 3, so we need to test f of 2, and we also need to test f of 3. When you put f of 2 through, so that's sine on your calculator in radians mode, remember. So sine of 2 minus ln of 2. If you do that, you'll get 0.216, and you'd use the same for 3. So sine of 3 minus ln of 3, you'll get minus 0.957. So we'll just say f of x is continuous, and the sign changes therefore the root lies between x equals 2 and x equals 3.